Today's learning target is I can draw translations and reflections on a coordinate plane. Today we're going to be talking about types of movements with geometric figures. And the first one we're going to talk about is called a translation. Another name for a translation is a slide. You've maybe heard that before. So a translation or a slide is when you move a geometric figure one way or another without turning it. Okay, so I could slide it up, or I could slide it down, or I could slide it over and down. That's a slide or a translation. And the way I remember that slide and translation are the same thing is slide has an SL in it, and so does translation. A geometric reflection is basically just a reflection over what we call a line of symmetry. So the reflection of the image will be exactly the same, but we reflect it over that line of symmetry. So we take the exact shape and we flip it, just like I did there, over the line of symmetry. Now, I'm going to make my line of symmetry the x-axis there. And so you can see right now this is the exact original figure as this, and I went it was originally 2 below the x-axis, and when it's reflected then it would be 2 above the x-axis. Okay, so here I changed the figure a little bit, but I want to show you what a reflection over the y-axis would look like. So here's my figure. Now I created a reflection of it, and now I see that it's one line off of the y-axis there, and so I'm trying to carefully place it there. So the line of symmetry in this case would be the y-axis. It's one off. I'm slightly off. I'd have to move this one down just a hair here, but you can see that right here these two figures should be exactly the exact reflection over this line of symmetry. Sometimes you'll hear people refer to reflections as flips. And one way you can remember that is flip has an FL in it, and reflection has an FL in it. So if we're asked to translate an original figure 2 places to the right and 1 place down, translate has the SL, it means the same as slide. So what we want to do is take each point and we're going to move it 2 places to the right and 1 place down. So here's point A, 2 places to the right, 1, 2, 1 place down. So I'm going to place my new point A, and here's how I do that. I put an A with a little slash above it like that. Now new point B goes 2 places to the right and 1 place down, so it's going to end up right there. So I place my dot there, and I go and I place the new B right there. Same thing with C, 2 places to the right, 1, 2, 1 place down, ends up right there. So I'll put my dot there, and I'll make sure I label it, new C, and my new D, 2 places to the right, and 1 place down right there. So my new D, ends up right on that dot. It's tough to write on the iPad sometimes. So those would be the corners of my new figure, and then if I created that figure, it would look just like that. Whoops, and did you realize the mistake I made? I didn't label my new D. Gotta make sure I do that. So the last thing we're going to do here is graph a figure and its reflection over the y-axis. So right here, we're going to reflect it over the y-axis. So the first thing I have to do is label my points, and so I'm going to do that kind of as I'm talking here. So I can see that's my -1, 4, and I'm going to label that as A. And then -2, -1 is going to end up right here. It's going to be my B. My dog is trying to lick my face as I'm doing this. It doesn't make it easy. And point C is going to be -5, 3. And that's going to put me right here. I'm going to double check that, make sure I counted right. 1, 2, 3, 4, 5. Yep, 3. Now, I have to connect these points. On the iPad, this is really tricky. You can use a straight edge. I'm going to do my best to make this straight. It's not going to be perfect. I just noticed I forgot to label that point C, so I'm going to do that as well. So it's point B right there, and point C. So now if I reflect this over the y-axis, okay, so my y-axis goes up and down, I'm going to have a new point A, a new point B, and a new point C. Remember to put the little slashes by them because that means the new point. So we are reflecting it over this line. So my new point A is going to end up right here. So it's going to be the same coordinate on the y-axis, but it's going to be the opposite from the x-axis. So it's going to be right here. So instead of being a -1, it's going to flip over to this side. It's going to be a +1 on the x-axis, and it stays, the y-axis, it stays at 4. Okay, so I'm just looking here, and I'm saying it's going to be the opposite of -1, which will be a +1. So I'll put that 1, and then my y-coordinate stays the same. So B is going to be the same, my new coordinate for B. Okay, my x-axis, okay, right now it's at a, oops, sorry, I was on C there. I was at -2 on the x-axis, so the new one's going to be at +2. So when I'm writing that, I'm going to go +2, and then on the y-axis, it'll stay at the exact same spot, right? Because the new point's going to be over here, but it's still going to be on the same place on this y-axis. So that means it's still going to be a -1. So it's going to be 2, -1. And then C is going to be the opposite of -5. So that would be a +5. And then the 3 would stay the same for the y-axis. So my new points are right there. So now I'm going to plot those. So here I plotted those points, and you can see there's my reflection over the y-axis. So I just, this is how I would do that. Now if they asked you to reflect it over the x-axis, you do the same thing. Okay, but instead of the x-coordinate being the opposite, then you'd have the y-coordinates being the opposite because you're flipping it over this line.